Hello again. This is our second video. On this video, you're going to learn how to do velocity and acceleration problems. Make sure you bring your book with you to the next class. If you don't, you're going to be sitting there for 90 minutes twiddling your thumb. Okay, we're now going to take a look at the symbols and the units in which they're given in. Displacement and distance. These two are very different, but a lot of people think of them as being the same. Displacement is from one point to another, and we don't care how that object gets from the initial position to the ending position. Distance is a little different, and we'll explain this as I go through the problems in class. Okay, X is for horizontal displacement, Y is for vertical displacement, and for right now we'll be working with horizontal, but in a few weeks we'll be working with both horizontal and vertical. Displacement and distance are both given in meters. The little symbol is M. Time is given as T. The unit is seconds. And because my 5's and S's look very much alike, I put in SEC for seconds. Velocity is kind of related to speed. Velocity is more with direction, whereas speed is not. We'll talk about that a little bit later on in class. Velocity is given as V. The initial velocity, or velocity 1, is the beginning velocity, and VF, the final, or V2, is the ending velocity, and velocities are given in meters per second. Acceleration is a change in velocity, and it's given as A, and the unit is meters per second squared. You'll also see delta in a lot of the equations, and that means a change in. For example, if I go from x1 to x2, that's a delta x. If I go from 10 meters a second to 100 meters a second, that's delta v. And the same thing goes with time. If I start with 30 seconds and I end up with 87 seconds, that's delta t. Okay, we're now going to get into the heavy-duty stuff. We're going to be working with formulas to find things. The 5 things that we can find with this are displacement, initial velocity, final velocity, time, and acceleration. Our first equation is velocity. Remember, velocity is given in meters per second. And what you need is a change in displacement over a change in time, or an initial displacement and a final displacement. Now realize that this will give you an average velocity between these two distances. We'll talk a little bit more about average velocities in class, and we'll also talk about something called instantaneous velocity in class and as it comes up in problems. Okay, acceleration, this is a basic equation for acceleration, a change in velocity or a change in time. And one of the nice things about your book is that usually they do not give you a beginning and ending time on either one of these. They just say 30 seconds or 45 seconds. And so you can just put the numbers in here without doing any kind of subtraction. But like with the velocity here, maybe the car starts at 10 meters a second and goes to 50 meters a second. So you would need to subtract the two, divide it into time to get your acceleration. Note that the acceleration can be positive for an increase in velocity, or it can be negative for a decrease in velocity. In layman's term, it's speeding up, it's slowing down. Now, what we're interested in are these 5 things: displacement, beginning velocity, ending velocity, time, and acceleration. And your book goes through quite a bit of pages going through different equations that can get this. But if you open your book to page 58, you have these 4 formulas. All of these formulas contain these guys in one way or another. And in order to solve for something, you need to know 3 of them. So in your problems, they may give you displacement, initial velocity, and final velocity, and then ask you to find time. Well, if I know this, this, and this, I know 1, 2, 3, then I can get the fourth thing. If I'm looking for these, if I have these three here and I'm looking for, let's say, acceleration, okay, I have my final velocity, I have my initial velocity, I know my displacement, and I define my acceleration. It's actually fairly easy. It's a process of elimination. You have 6 formulas here, and you have to decide which one will get you the answer that you need. Okay, let's open our books to page 44, and let's take a look at the first question. It says that Heather and Matthew walk eastward with a speed of 0.98 meters per second. If it takes them 34 minutes to walk to the store, how far have they walked? Okay, so now we have a general idea of what's going on. Let's take a look then at our data that we can pull from this. Okay, it mentions that they're walking with the speed. Speed is kind of a velocity. And also you can see that it was in meters per second, and so that unit is associated with velocity. Okay, we have 34 minutes. 34 minutes is a time, but it's not going to work right now with the velocity, because this is given meters per second and this is given in minutes. So if I multiply this by 60 seconds, I have 2,040 seconds. And then, of course, I want to know how long in terms of a distance did these folks travel. Okay, so I can look back at all my equations, and this is probably the best one that will give me the quickest answer. My velocity goes here, my time goes here, my unknown is here. Okay, then I multiply both sides by 2,040. And so this guy comes over here. This times this gives you 1,999.2. Significant figures plays a role in this. So 2,000 meters, and I box in my answer. This is the way your questions should be, your problems should be answered. Nice and neat and clear, and I can see everything that's going on. Okay, if you'll open your book to page 49 now. Let's take a look at problem 1. As a shuttle bus comes to a sudden stop to avoid hitting a dog, it accelerates uniformly at minus 4.1 meters per second square as it slows from 9.0 meters second to 0 meters per second. Find the time interval of the acceleration for the bus. Okay, you've read it for understanding. Now you're going to go back and see what kind of data. Well, you have 2 clues about the final velocity, because the first one says at a sudden stop, so therefore the final velocity has to be 0. And then a little bit later on it says going from 9 to 0 meters, so you have a clue twice given that the final velocity is 0. They tell you the acceleration is a negative 4.1 because it's slowing down, and you also have the meters per second squared, which should help you figure out that it's acceleration. And they tell you that it starts at 9 meters a second, and the meters per second tells you it's a velocity. And then you have time unknown. Okay, if we come over here, there's the formula that I'm going to use. I put my acceleration in, my final, my initial, my time. Okay, the time gets multiplied here and here. I divide negative 4.1 here and here. So these guys really just exchange places. I divide this into here using significant figures. I round this to 2.2 seconds. Once again, if you notice, I've laid out my data. You'll get credit for that. I've put the correct formula. You'll get credit for that. I worked it out so you can see the math. I would give you credit for this, and you have your answer boxed in with your units. Okay, let's now turn to page 58, and let's look at problem number 3, A and B. Once again, read for understanding. A car accelerates uniformly in a straight line from rest at a rate of 2.3 meters per second. A, what is the speed of the car after it has traveled 55 meters? And B, how long does it take the car to travel 55 meters. Okay, so let's look at this. It says starting from rest, so our initial velocity must be 0. It gives us an acceleration, okay, and it's kind of hidden. It says a car accelerates, blah, 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 at a rate of 2.3 meters per second, so squared. So the acceleration is at the beginning, but it's now calling it a rate. But if you notice, it has meters per second squared, and then it gives a distance, and we want to know the final velocity. So if we look at the formulas on page 58, this one seems to have everything that we need. We are looking for a final velocity. We have an initial, which is 0, 2, 2. The acceleration is given, and the distance is given. So this drops out because it's 0. Multiply these guys together, you get 253. This is velocity squared, so you need to find the square root of this, and that's 16 meters a second. For 3B, we want to find the time. We know the acceleration, the distance, and the beginning velocity. They were all given to us, but because we solved A, we also know the final velocity. And because I have 4 things, I could use quite a few formulas up there. I probably could use 4 of the formulas or 3 of the formulas to find okay, so now let's take a look at 3B. We want to find the time. The acceleration was given. The distance was given. We knew the initial velocity was 0. And because we solved for A, we know that the final velocity is 16. Now that we have 4 knowns and only 1 unknown, we could use quite a few of the formulas on page 58. I chose this one for no particular reason. Okay, but we have a distance, we have initial velocity of 0, we have a final velocity of 16. We divide this by 2, we get 8. 8 goes into 55, and we end up with a time of about 6.9 seconds. Like I said, there are other formulas that you could use. This is the first one that I came to and said, okay, it has everything that I need, so I'm using it. And for those of you who have watched the complete video, you might want to study this chart or copy it down. It will really benefit you for the next class. Have a good day. Bye.